Welcome everybody to DQE Communication presents fiber construction to commercial buildings. Today's agenda is going to be welcome and introductions, why fiber, network planning, network design, agreements, fiber construction, and a little bit about DQE Communications. First, I'd like to welcome everybody to the webinar. We are definitely happy to present this material to you. My name is Tom Neugebauer. I am Senior Manager of Project Process Management, and I have with me today Amy Leitner, Permits Engineering Coordinator for DQE Communications. Okay, so let's get started by asking a simple question. Can you identify the telecom providers that currently service your commercial building? We're going to get into this in more detail in a little bit, but it is a simple question, but it's an important one, I think. So why fiber? Let's begin with what's driving the need for fiber. Okay, 5G and Internet of Things. 5G and Internet of Things is driving the need for fiber, along with mobile computing, data mining, business analytics, cloud-based applications, HD video, and edge computing. And let's also talk about the key benefits. Higher bandwidth, unlimited. Fiber is virtually unlimited, which makes it possible to use huge volumes of data by changing out the optics and not adding more cable. Fiber optic internet is many times faster than even the highest speed copper internet connections. So improved internet speed. A little bit about the security. Fiber cable are less vulnerable to cyber attacks. It's much harder to tap into a fiber cable than it is a copper cable. And we'll cover this again further too, but fiber cables are made of glass. So once that glass is broken, the signal escapes. Latency. Latency. Latency is a term used to describe delays while processing data over a connection. Lower latency offers better voice quality and enables faster uploads of huge files without disruption. And also the cloud. More companies are going to the cloud. Think of a CRM, Office 365, Amazon, all of those. Fiber means faster access to the information and applications. And we touched on this a little bit already, but it's more durable than copper. The signal strength does not degrade as quickly over a distance. It will last up to 40 years, if not more. So fiber is made of glass, which we talked about, which is tougher material compared to copper. It is also, in most cases, smaller and lighter in weight to install. Okay, so let's talk about what's in it for you as a building owner. Provide your tenants with choice and competition. So being able to provide tenants with a choice of service provider and for their internet, having fiber access makes your property more attractive to companies. This is a benefit for business renting out space for tenants long-term or for nomad-style offices. Also, we can talk a little bit about smart building connectivity solutions. Fiber optic is resilient high-speed network infrastructure, allows the utilization of technology to make your building smart. So we talked a little bit earlier about Internet of Things. So having the Internet of Things, implementing sensors, elevator, thermostat, security cameras, smoke alarms, those type of things help you concentrate on your tenants. Future-proof your property. Fiber connectivity adds an average of 0.1% to a property's value, according to a study by the University of Colorado. So providing cutting-edge infrastructure is positioning yourself for the long term. Depending on good, reliable fiber connectivity continues to increase. And the properties that remain ahead of the curve are in a better position for success now and in the future. You can also see another market research found that buildings with internet connectivity is second only to location in importance to tenants when seeking office space. So the key is to invest in the future of your property to ensure your viability. And if by chance you're building a new building for a tenant or tenants, establishing your fiber entrances from the start is key. It's kind of like a build-to-suit idea. So bring the fiber into your property early, prior to completion, so you are set up for success right from the start. There's no construction disruption later. Okay, so now we're going to go over the 4-step process. We have network planning, followed by network design, then rights of way, and fiber construction. So let's talk about the first step, step 1, network planning. What is network planning? Network planning is a process that encompasses a topological design aimed at ensuring a new fiber network service meets the needs of customers as well as the provider. This process could be backbone construction, following make-ready, and or lateral fiber construction from the backbone to the building. Network planning for an organization involves assessing the cost-effectiveness options, which benefits the customer and the company. Planners may also consider routes that provide the opportunity to serve additional customers. Rather than building the shortest and cheapest solution, a longer, more expensive solution may be built to fill a network need, such as closing 2 laterals to make a ring and redundancy. And we'll cover that a little bit. I do have an example. We'll just bring this example over here. And what we're looking at is a Google Earth depiction. So this is something that a network planner, if we get, let's just say this is the Robinson Township area, this is Home Depot. So let's say a company like DQE gets a potential customer, say Home here. So the network planner will then use Google Earth and the tools to plan the route to the building. And as discussed, we may be passing additional buildings here so that we can potentially service them in the future. So this, by using Google Earth, it gives the network planner a good, clear indication of how to plan the route, the fiber route to the new building. Okay, now we're going to talk about the network design. Engineering prepares a network design. Typically, what DQE uses is computer-aided drafting, or CAD, and we'll look at an example of that here in a minute. Now, other companies could use SolidWorks, SketchUp, Autodesk, Inventor, DraftSite, OSP Insight. There's many different ways companies can use engineering software to design a route. So we'll go over a quick example of a CAD route. And while I'm pulling that up, DQE uses a device known as an IKE. It's called IKE, and it gathers pole information. And in that pole information, we can get attachment heights, all other companies that are on that pole, and identify it. And what that also does is it gives us GPS locations, so that then we can take it into the CAD drawing. Okay, here's an example of AutoCAD and what it looks like. So after DQE and the engineers go out and design a route, so you have the network planner, they plan the route, then we have the engineers who go out and design the route. The engineers will then be able to, using the IKE device, be able to come in and plot these locations, these pole locations, and create a AutoCAD drawing, such as you're seeing here. On here, we'll also identify each pole owner and heights that DQE will attach their fiber to the pole. Also on here is other service providers and where they sit on the pole. So that all encompasses the engineering process. We are now going to turn it over to Amy, and she will now explain step 3 of the fiber construction process, which is pole attachments and right-of-way agreements.
Hello, I'm Amy Leitner, and I'm a pole permitting coordinator for DQE. And I'm going to start off talking about the pole application process and public and private agreements that are needed to attach to poles. So in respect to public agreements, those include your pole permits, which is a permit to attach to a utility pole. Pole permits are obtained by applying to the pole owner for authorization to attach to the requested pole. You may also need a permit or license to work within a municipality. Municipalities that require a permit or license each have their own process and standard to meet to gain that approval. These types of permits and licenses are usually managed by a pole permitting group within a company. You may also need private agreements. Those private agreements may be an agreement to work on private property or in a private right-of-way. A building access agreement may also be needed to allow for placing facilities within a building. An interstate crossing agreement, a turnpike crossing agreement, or a railroad agreement may also need to be obtained. These agreements are usually managed by an access management group within the company. While these tasks are usually managed by various individuals within an organization, they are usually worked on simultaneously. So, for pole permitting, the first step in the process is to identify the poles needed. Once you figure out what poles you need to attach to, now you need to identify the pole owners. I usually start by looking at the pole tags. Pole tags on each utility pole really gives you a lot of information. So you look at the pole tag and you identify the pole owners. You may be wondering why the pole owners are so concerned about who's attaching to their poles. Well, the pole owners have a lot of responsibility. They need to maintain the safety and integrity of their poles. So it's really important. And so once you've identified the pole owners, the submission process begins. This is where all the fun starts. So poles are generally owned by the power company, the local ILEC, CLECs, and sometimes the local municipalities, or any combination of these entities. When it comes to the power companies maintain and manage two different types of poles, and these poles are very different. Transmission poles are the interstate highway of electrical delivery. These have a voltage of 100 kV or 100,000 volts. These poles are reviewed by a special team of engineers who follow very different special regulations. Attaching to a transmission pole adds time and cost to the process compared to distribution poles. Fiber providers cannot avoid these poles during the route planning process, as it is not always easy to detect which poles are transmission versus distribution. Providers may not know until they've applied that they're actually designated transmission poles. Distribution poles are the poles that provide electricity to homes and businesses and are a lower voltage, 13 kV or 13,000 volts. Power transmitted on these poles is stepped down or reduced by a transformer, then sent through distribution lines to service our homes and businesses. They carry less voltage, therefore local engineers from the power company are usually able to review and process those applications for attachment. So ILECs are another vast majority of the poles that you will apply for. And ILEC is really just a fancy way of saying your local exchange carrier, which is your local telephone company where you have your landline through. A much smaller number of poles are owned by CLECs. And CLECs, again, is just a fancy way of saying your competitive local exchange carrier or your local cable TV or fiber provider. CLECs entering the marketplace has been great for consumers because it's created a competition among providers while providing consumers with choices of providers and services. But from a pole permitting perspective, it means more attachments on the poles and more entities to coordinate with. So now you've identified the pole owners. The next step is to submit your applications. This process can look very different for each utility owner. Some are web-based, some still want paper applications. Some utility owners are very involved, while others are very hands-off. So once you've submitted your applications to the pole owners, we usually try to coordinate a joint ride. A joint ride just means getting everybody together to go out and look at and review each pole. As part of that review process, the pole owners are going to review each pole, provide the new attacher of an assessment of that pole, and communicate to them any make-ready that is needed for the new attacher to attach to that pole, and they're also going to give you the cost associated with that work. What is make-ready? Make-ready is really just the work that is needed in order to make a pole ready for a new attacher, such as rearrangement of the existing attacher's position on a pole, or even a pole replacement. Make-ready is a very important part of the pole permitting process. Make Ready provides a new attacher with a safe means to attach to a pole. So once the Make Ready's been determined, you've received your invoices, you've made payment for the Make Ready, it's time to start coordinating all that Make Ready. Sometimes the utility companies will help you coordinate that, and sometimes it falls on the new provider to make all of those arrangements. On the last slide, you're going to wonder, why is this process even necessary? Why do we go through all of this work? On the left side, you'll see, here's a nice picture of a nice safe pole. There's room for people to attach safely without any issues. And then on the right side, here's what can happen when you don't have this process. Okay, I'm going to turn it over to Tom to talk about right-of-ways.
Okay. Thank you, Amy. Yeah, as you can see, the process just to apply to get applications to put our DQE's fiber or whoever's fiber up on a pole is quite an extensive process. We certainly don't want to have issues that are pictured on the right-hand side. Okay, so a little bit more, step 3, more on the right-of-ways. Applications, expected timelines, considerations for specific rights of way. Amy kind of touched on some of this already, but application requirements, every right-of-way requires a different application, and requirements vary. Expected timelines, there's often multiple factors that dictate timelines and approvals for different right-of-ways. For example, if a third party is required to be on site or install has to happen overnight to avoid traffic rains, etc., it can dictate timing or delays. Consideration for specific rights of way, for example, to cross an interstate, PennDOT needs to be involved, as well as the state police. This coordination and availability can dictate timing and or delays. So all of these right-of-ways and their requirements can impact a fiber build. So types of access agreements. There's all kinds of different access agreements. We spoke about a couple of them, one of them being rights-of-way, easements. So they could be private easements. They could be, there's several different easements. Right of entry agreements, building licenses, land leases, co-location agreements, commercial lease agreements, pole attachment agreements, which Amy spoke about, base license agreements, service license, office agreements, fiber optic access agreements, hub agreements, MSA for industrial parks. So that would be master service agreements for industrial parks, license agreements for fiber optic cabling. So right of way submission systems, the coordinator must visit many different systems to find out who owns the land. How do I get across it? Is there a way to get across it? Will they allow us to get across it? So once you start getting into private agreements, that can definitely impact the time to build, which is critical. Okay, so step 4, fiber construction. Following all the approvals that we've talked about, Amy talked about, I just talked about, getting on the pole. Next is hopefully within a reasonable amount of time, we can get to the point where we can construct the fiber. Following all the approvals and make ready processes being complete, the fiber will then be constructed as part of the provider's backbone, following their lateral fiber construction to a building. So in some cases, we're talking about backbone fiber, and you might be wondering what exactly that is. And then also lateral fiber construction. So just to elaborate a little bit on that, the backbone fiber construction is, say, your main fiber construction. It is our backbone fiber where multiple rings that we have are delivered. And then lateral fiber construction is pretty much the fiber from the roadway into a building, perhaps. All right, so that is kind of like the differentiating between the backbone and the lateral fiber construction. So, typically after fiber construction to a commercial building, depending on how the construction had to be done, whether it be underground or maybe an aerial attachment, a lot of fiber companies and specifically DQE Communications, we install a equipment rack, typically in a common area within the building, where that's where we'll put our network equipment or end switch equipment to provide service to one of your tenants. And in that area, typically we put a box on the wall, which will house that equipment. So those are some of the things that you can expect from your fiber provider. So we covered pole replacements. So in the construction process, we talked a lot about the designing, the planning, the designing, the attachments and permitting, make ready. We also talked about, how fiber providers get fiber to the building. And we touched a little bit on the impacts to the process, but there's a lot more impacts to the overall process of building this backbone slash lateral fiber to the building. If there's pole replacements, Amy touched on distribution, the difference between transmission and distribution poles. So a lot of times we don't find out from the pole owners that they may not allow us our planned route and our engineered route. They may encompass transmission poles, and they may not allow us to attach to those poles, which obviously is going to impact the whole process. There are one of the bullets up here is business refusal for outages. So just to expand on that a little bit, as Amy was talking about, applying for to be on the poles and then make ready construction. That make ready construction is all the other companies that are on the pole, doing their work to allow us to attach fiber to that pole. So, this encompasses the electric providers as well. So oftentimes, if there is electrical make ready that needs done, customers of the electric company and businesses have to take an electric outage for the electric company to do that make ready. So there could be, think of like high profile businesses, and they may have reasons not to take an outage, even if it is a planned one. The other impact, we're in Pittsburgh, obviously a lot of storms and things of that nature that happen here. And what happens after a storm mode, the electric providers are running around to fix everything. So their manpower is very limited to work on any make ready stuff. So obviously, utility companies electric companies going in storm mode is a huge impact that could delay this overall process. Right-of-ways and agreements. We talked briefly before, pretty much in detail, a lot about right-of-way and agreements and private agreements that are needed. So, in my opinion, this is something that could be overlooked and really impacts the overall time to complete this whole process. And then last but not least is just material availability. This is a competitive industry and there's a lot of companies out there and there's a high demand for fiber. So our providers, manufacturers of fiber, sometimes there is less availability than others. So, getting that material in and on time can obviously impact the overall process. Okay, so we covered everything as far as getting fiber to your building, what you can expect, and how fiber providers do it. In essence, I'd like to take just a couple minutes to talk a little bit about DQE Communications, established July 25th, 1997. We are in Pittsburgh, PA, as I mentioned earlier. We are a subsidiary of Duquesne Light Holdings, and we are the largest privately owned 100% fiber optic network in Western Pennsylvania. So we're ideal for businesses of all sizes, small and medium. We talked about different product offerings, or we'll talk a little bit about different product offerings that we have. So here is a very scaled down version of the DQE map. You can see in the dark blue is our existing plant. The green is where we are expanding to. Our current expansions right now are in the Fairmont, Morgantown to Fairmont, West Virginia. We're also expanding in Harrisburg, Pennsylvania. So DQE is a leading provider of high-speed data networking for businesses of all sizes, as I mentioned, carriers and wireless providers. As far as our different offerings, internet, we have 4 service tiers of offerings: basic, dedicated, highly available, and a relatively new product is Internet Lite. All 4 of the internet tiers feature 100% symmetrical upload and download speeds. DDoS mitigation. This is a security solution for organizations looking to protect their network from disruptive and compromising distributed denial of service attacks. DQE detects, responds, and mitigates these attacks, improving network availability and quick response times to dedicated industry experts to offer customers a hands-off solution. Metro Ethernet, with a commitment to committed speeds of 10 megabits per second all the way up to 100 gigabits per second. Customers can extend their Ethernet LAN over DQE's wide area network, connecting each user via a redundant, secure 100% fiber optic network. For example, like a large bank in the area connects each of their branch offices with their main data center to pass data between offices, is one example. DQE also provides wavelength services. This is a premium solution with high service level agreement, or the industry term is SLAs, offered at low latency, point-to-point connection over a single fiber. So this is good for customers that have high bandwidth needs, but don't want to maintain their data network connections. We also offer dark fiber. Dark fiber is, just as its name implies, DQE does not light it. We don't put our own electronics on either end. So this is a secure, dedicated, and scalable option with high capacity bandwidth. You get fiber from us, the dark fiber, and then the customer ends up lighting it themselves with their own network components, where they'll be able to maintain direct operational control of their network at a fixed cost. So this dark fiber is good for very large bandwidth customers that have an IT that wants to manage their own network. Cloud solutions, private and direct connectivity to top tier cloud service providers. DQE partners with cloud service providers such as Amazon Web Services and Microsoft Office 365 to provide fast and secure data performance to the cloud to meet any business demands. SD-WAN. This end-to-end turnkey solution integrates seamlessly into existing infrastructure as an overlay to your network and can connect businesses across multiple sites, cloud services, or off-site data centers. DQE also offers co-location. We have 2 state-of-the-art co-location sites, one in downtown Pittsburgh and the other is in Butler, PA. So both locations are environmentally controlled and have access to DQE's fiber network, feature 24/7 multi-tier card access systems, and provided and installed lockable cabinets, and are carrier-neutral facilities. So why DQE fiber for your tenants? Here are a few other benefits our customers enjoy. Like we mentioned before, 100% fiber optic network. We build it, we maintain it, we own it. There's no one else to call if you have a question about their service. We offer a single point of contact. This keeps DQE directly invested in the integrity of the network and allows faster response times. Customer network solution, flexible customer network solutions for organizations of every size and industry with unrestricted bandwidth access and scalability. Redundancy, protected, unprotected services topologies. Our speed, networking at the highest commit speeds with unrestricted symmetrical upload and download speed, as I mentioned before, 10 meg all the way up to 100 gigabit. Reliability obviously is huge in this industry, and here at DQE we have self-healing fiber optic ring-based architecture built on redundancy over the Ethernet and network solution in the event of a fiber cut. The network automatically heals itself. We also offer 24/7, 365 network operations center, providing customer experience, dependable local support. Customers can reach the right person to talk to faster that is knowledgeable about our network and their service. Access for customers to a secure customer web portal to monitor their bandwidth usage and network performance. This is what we call our CCC. So every customer has access to the Customer Control Center. DQE provides service directly to versus other provider who only go to the NID. So we talked about, running fiber to the telecommunications closets. A lot of other fiber providers or other telecom companies only run to that point. It would then be the responsibility of the end user or the tenant to run the connection in between the telecommunications closet and their space that they rent from you. So, but DQE does that connection as well. DQE's reputation in the marketplace: we're responsive, deliver on our commitments, and our customer focus. These are some of the comments that we get from our existing customers. I'm going to show you on the next slide. Also, the other important thing to remember is DQE Communications is committed to safety, the safety of our employees, customers, and everybody that we deal with. So we are safety conscious workers. On your property, we have 0 OSHA recordable accidents within the whole history of DQE. Okay, and with that, I'd like to thank you. This ends our webinar. I'm leaving you with several of our customers and their comments about how happy they are with DQE's overall service. So I hope this webinar kind of answered some of your questions about how the whole process works. We went into a lot of detail about in a short period of time on what it takes to get the fiber from a planning state to a completion state at your location. So thank you very much, and we look forward to doing this again in the future. Thank you.